It's time to start collecting your best student projects for the next Student Sizzle Reel. If you go to UnrealEngine.com and search for a blog called Tips for Submitting Your Unreal Engine Projects for the Annual Student Sizzle Reel, you'll find some advice that can be very helpful. Things like making sure to record at the highest resolution and stable frame rate, and also things like making sure that you don't use default textures and characters and assets, and making sure that you submit only one project at a time. Once you're ready, make sure you submit the project to YouTube or Vimeo and then send us the link to student.reel@unrealengine.com. Make sure in the description of the video that you submit the project name, your name, team members, team name, and then the school name. We are looking forward to the submission. The reel is one of the best things we do every year. We're very excited about it. Please make sure you collect the work and send it to us. And we're looking forward to all the submissions from around the world. Thanks much. Hello, everyone, and welcome to another Educator live stream on Friday. Woo, Friday! We are very excited today to have Paulo Sousa, who is our education evangelist in Brazil. And today we are doing a live stream called Building Next-Gen Environments in Unreal Engine. And, this is a stream that we're really excited about. As usual, we have Mark Flanagan from the United Kingdom, our evangelist and education manager in Europe. And we've got Tom Shannon, who's joining us from Colorado. As usual on our stream. And as I mentioned, we've got Paulo Sousa, who's joining us from Brazil. And hopefully you guys have had a chance to see a video that he did on this topic, maybe about, 2 or 3 months ago. And if you haven't, you're one of 145,000 people who didn't get a chance to see it on YouTube because it's been a very popular video. So we wanted to have Paulo join us to talk about these next-gen features inside of Unreal Engine and really to get into the topic because, we've been talking, for a couple weeks about next-gen features in Unreal Engine and about some of the work that Paulo did in this to build this video. And I know when I saw that video and started chatting with Paulo about this, I was really impressed that in that video, he could just sort of jump in there and build that environment so quickly. And with regard to the learning community, the teaching community, and once again, we always stress on the stream that that doesn't just mean universities and high schools and secondary schools, but that's anyone who's, training people at companies, who's doing virtual production, who's maybe teaching other game studios, that really, these features are for everyone, and the engine is only getting more rich with these types of features. So we really wanted to focus this stream on talking to Paulo about how he jumped in there and worked with these features and really expose them even more clearly. I know that you've, Paulo, had a lot of questions about these features. So before we dive into it, maybe you can just tell us a little bit about yourself a little bit more. I know you've done a lot of work, not only with this, but you've had a rich history at Epic. I've known you for a number of years now. We've worked together. We've traveled together. We've done conferences together. You did some work on some other things that we want to talk about during the stream. Just tell us a little bit about yourself, and then we'll get into all that stuff.
Thanks, Louis, and hi, everyone. Yeah, we've been doing reaching developers mostly in Brazil for me since 2015. Before that, I used to have to work on game companies. My own game companies was like mostly entrepreneur most of my life. And then since I joined Epic, the evangelism work, it's writing between the technical side and a little bit of the developer relationship side, and sometimes even a little bit of business development. So we sit like right in the middle, don't go very deep technically, but we should be able to onboard companies and indie teams and new teams in general to start using the Unreal Engine. So yeah, it's been a very interesting job for all these years, and once in a while there's like an opportunity for us to to show what we've been experimenting on the technical side of the engine. showing some demos like the one we did with the environment demo.
So if you, by the way, hear some construction, Paulo's been so successful at this that he's having a swimming pool put in and a whole new wing put into his house. And so there's construction going on. And I'm just teasing because that's not exactly at all what's going on. There's actually construction going on, I think, in his house or next to his house. But, you know, it's a live stream, so it's all live, and that's what happens. So we're going to live with it.
For my neighbors.
We live with it, and that's the way it goes, right? So yes, we will enjoy it, and we will just have a good time. But you know, I had mentioned that you had done some other work, and we'd done some work. We'd done some learning materials. We worked on a mobile game before where it was Party Crashers was really a lot of fun, where we taught that for a while. And, you know, it was kind of like this airplane in this apartment. And we'd done a bunch of videos on that a while back. And I don't remember what happened with that, but it was really cool. And we taught that for a while. And then you went off with Sam Dieter and you made this other really amazing project. Maybe you guys on the stream had utilized that and learned from it, but you played a really principal role in working on something called Action RPG. And that was a really valuable project because, you know, a little bit of history on Action RPG. I know that there were a lot of people interested in mobile development, really high caliber mobile development, particularly as it would deploy on Android phones and iOS phones, and mobile devices in general. And they wanted to understand how C++ worked, with Blueprint particularly, and how to integrate all the bits and pieces. And you really played a key pivotal part in, you know, helping to build that project. Can you tell us a little bit more about your role in Action RPG before we get into today's stream?
Sure. It was, again, right in the middle position. It was me and Sam initially. So Action RPG actually was born out of a project that was started in Epic Korea because they wanted to do some RPG kind of game for mobile, focused on mobile. That project never really took off there, but then we got those assets, we got this project as a basis, and then we built over that, at least over the concept, what Action RPG really became. And Action RPG game was, really, we wanted to make our main mobile project to be used as a reference for other mobile developers, where they can, you know, if they need a live and maintain point of reference for them to implement specific features on how to make a mobile game using Unreal. So it's I mean, quite well optimized. I mean, the game has a really smaller scope in terms of the size of the levels, the size of the world, but it does use some advanced features in terms of gameplay of the Unreal Engine. Specifically, the gameplay ability system is like a very complex system if you're making these kind of games that have like RPG elements. But we also have some level of interesting kind of like advanced UMG for the UI, and we do have some AI and behavior tree usage, but in a simple form that people can actually use as a reference. So it's not that complex for them to reuse part of these assets and part of the project as a basis for their own project. That's what's the main goal of it.
Right. And there's, I think, 2 or 3 streams that were done around it. So those are available on YouTube. If you want to go back and watch some of the streams about Action RPG, there's a whole bunch of documentation on Action RPG, and it can be downloaded from the marketplace as a project that you can go back and learn from, as well as you can download the actual playable games, at least on the Android store. I don't know if it's still available on other platforms. So, you know, Action RPG is a really good learning resource. But then you went off and, like some of the other evangelists, you know, went off and decided to take on some other features of the engine. And one of the areas that you wanted to focus on were some of these open world, environment, terrain, landscape, foliage features. And you you built this video that you released, and now it's got 140, almost 150,000 views on YouTube, and people really liked it because, I remember when I watched it, a couple months ago. I don't remember exactly how long ago it was. I was just blown away by the fact that you just built this environment really quickly out of nothing, and we're really excited to have you here to talk about it because I think any of you who've had a chance to see it. You just kind of whoop this thing out. And, of course, the engine is very powerful and it does a lot of these things. And these features have been accumulating in the engine and they're going to continue to accumulate. And we're going to talk about them here. But, tell us about the making of that video and what brought you to sort of focus on that topic a little bit.
Yeah, initially we were planning some of those videos for events in the beginning of the year. But then plans have changed, so we changed the schedule of release for these. We wanted really to try to make something that was like really quick, that we don't need to show like a lot of how to actually make art, but how to reuse art to make like a beautiful and interesting level, interesting scenario. But trying to focus on the latest features. One thing that I like a lot about working with real-time graphics is that there are always opportunities for you to optimize things and make things that are usually very hard to do in real-time engines, because you need some level of optimization or some smoke and mirrors magic to make that level of graphics work. And so that's why it was interesting for me, because we use, I mean, even though it looks very, very simple, but under the engine, there's like some really neat techniques on how to actually, some of these videos are able to be delivered, like the runtime virtual textures, which is like a recent feature, I think from 4.24 or 4.23, I remember for sure, that actually allows us to make to have some details to the level that were not impossible. I mean, they were not impossible previously, but you have to go circle or maybe even build a similar system yourself. So these kind of small features that we add from time to time, that with a little bit of creativity, you can like come up with great ideas for new techniques and how to make not only your scene more beautiful, but also performant.
Right.
That's awesome.
Right. Yeah. And so, terrain features have been in the engine for a long time. Texturing terrain has been in the engine for a long time. But, I remember digging into the terrain features in the engine, and it was not especially super easy to use these and to make a large terrain. But then not that long ago, not that many versions of the engine ago, Ryan shows us the landscape blueprint brushes and then the virtual texturing tool set. And all of a sudden it's kind of like wizardry. It's magic, right? You put down a couple splines and then you get this incredible amount of detail in the terrain. And of course, when Ryan Brooks goes on a stream and he shows people how this stuff works, everyone's like, of course, yes, if Ryan can do it, I can't do it. Right. I know that's what I think when he shows us this stuff, but then you come out on this video and you're like, well, yes, it actually is not that hard. Here you go. And we're going to just build it over the course of the next, your video is not that long. It's like 20 minutes, half an hour. So you kind of bang it out and you demonstrate that, but also you use the virtual texturing system and you use Quixel Megascans, and there's a lot of things that come together. Also you're using the edit layers and the tree and foliage tools in the ecosystem. And of course, we've been able to paint trees and been able to paint foliage for a long time, but you're actually using a lot of proceduralism and procedural tool sets that mean that you don't have to manually put down a lot of things in the environment. And all of a sudden you get this, and not all of a sudden, nothing's all of a sudden, but, based on some actual math and calculations, you can make a pretty significant environment very quickly. And I think that's what we want to get into here, because, from a learning perspective and a teaching perspective and a training perspective, the key is that everyone should be looking into these tools because they're incredibly powerful, not only in the context of games, but in the context of anyone who needs to build environments in a virtual production capacity, or in the context of architecture, AEC space, and anyone who needs to just make large environments, which I think real-time environments are only going to get bigger and more expansive, and the desire, because Unreal Engine can render them very quickly, everyone should learn these tools, because we're only going to make more of them. Now we have a water system, we've got a sky atmosphere system, we've got a volumetric cloud system. So the idea of making enormous virtual worlds is really at everyone's fingertips. And though some of these features are experimental, they don't stay experimental, they just become available to everyone, right?
Yeah, and I think that one key word that I really wanted to bring to this video was the non-destructive aspects of those features. Is that most of these features, I mean, we're not using like pre-baked light maps, as the lighting in Unreal has been vastly improving even faster now with the the next generation. I wanted to try to do everything real time, but if you look from the from the level designer or from the world builder perspective, all of that, including the geometry, the terrain, the trees position, the grass, everything can be changed dynamically in the editor. They're all like non-destructive. I can change the water body's position. I can change the mountains. I can move them around. So there's no like pre-baking or re-importing meshes or re-importing height maps. I think that's crucial for open world games, because once the game is exported from the engine to be built from the engine, then some stuff are going to be baked down for the sake of performance. But while you're editing, while you're building the world, to be able to have these non-destructive tools are key, because games and environments, it's the kind of thing that you need to iterate frequently and change them frequently to get to the fine point.
Yeah, that's
that iteration loop is one of the things also that I think is so attractive in real time, and it's why film and architecture have moved over so quickly, is because that iteration loop is so much quicker. And so now I think we're all very aware anytime that we have any sort of pause or stop in that iteration loop. So being able to get rid of those is really kind of where a lot of optimization is now. Now that rendering is gone, getting that iteration loop and being able to test and get things out the door is so key. And these tools are so cool. I really can't wait to see a little more in depth, because I'm like Lewis. Like I've watched some Ryan Brooks videos, and I'm like, that's neat. But I feel the same intimidation sometimes, that I'm like, I don't know that I could get that to work. So it's often really great for me to see other people taking those tools and using them, and really kind of showing us where they work, where they don't, and then really where they're going. So
I think we're very close to a point now where in a couple of years' time, people will look at the way in which we used to make environments, and they'll be sort of thinking about them the same way that we think about traditional photography, that what you had a piece of plastic you put in the back of a camera, and then you'd expose it to light, and then you'd take it out in a dark room, and you go through all these steps, and they'll think, and it took how long to do that? But I just do it all instantly.
And then you baked the lighting? What does that even mean?
But it will, in the space of a couple of years, people will not believe that we actually used to do the things we used to do, because it will be so intuitive and natural.
Yeah. Before we hand the stream over for you to show us this stuff, let's just talk a little bit about your experience in working with some of these experimental beta, say, feature sets, because when we release these features, they are experimental, they are beta. There is some documentation for them. We do streams on them, so you get to quite often to watch some of the key developers use them on a stream like this. But you were able to jump in there, and with some documentation, some ability to watch somebody else drive the tools, you were able to generate these environments. Can you share a little bit of the experience working with experimental beta tool sets?
Yeah, that the experience may vary depending on the level and depending on the, how can I say, depending mostly on the demand of the tool. If a tool is really well demanded, then when it's at the experimental stages, they're actually like very close to a shipping state, very close to done. So in general, at least the tools that I use for this talk, they were like pretty good. I think you will there are some challenges, sometimes mostly related to the UI. Sometimes the UI, or some people may call it UX, are not as streamlined, or maybe it's not really like at that level where it's following the entire engine uh, idea of how the UI should be. But then with a few months ahead, then things should get better. But in general, if you have like a good understanding how the engine works, the experience is not that bad really.
Excellent. Well, I mean, we're ready to hand it over to you and Woud, and we'll be monitoring the chat. So we'll maybe, if it's all right with you, Paula, we'll sort of collect some questions as it comes along, and pause every once in a while and let you answer some of these questions. And but
Perfect.
we're excited. Are you ready?
I am. I think I am.
Excellent. Are you guys ready in the stream?
I'm ready.
Yes. Cool. Well, have at it.
Okay. So let me share my screen for a moment. Can you see that?
Yes.
So here we are. This is a scene that looks very similar to the scene that I built in the demo. I mean, this is the same project. We are using the same assets, same everything. There are some minor changes to the layout, and that's actually how fast you can build other layouts. And then once you have like the general style for the scene, these non-destructive tools enable you to create like different layouts for using that same style very quickly. And this is just like a new one with a different layout than what we had in that video. And like we said before, this is not all of it, but most of it is kind of like randomly generated. Let me open this other map. This could be considered like a previous version of that. So what we can see here, we have a landscape. We have this huge static mesh that's going to be used just for a background. This is actually downloaded from a marketplace asset. And there are like a number of these in the marketplace. There are even some for free, and kind of like shows how powerful the marketplace is for you to create your environments and find stuff that may be useful for your game, for your project. And if we go into the landscape edit here, then you can see that we have two landscape brushes. One is this one called material only, where basically we're using just to add some noises to the. Let me turn off the grass. It adds like a slight noise to the terrain. If I turn that off, oops. If I turn, yeah, that's going to be some shader compilation. That should be fine. If I turn the other layer off, you see that it adds like a slight noise to the terrain, making it a little bit more natural. And then we have the landmass blueprint brush, which is the one who's actually generating these the hills and the the rock terrains. And this is all being based on these splines. So those splines define the area, and then we have like a lot of options that we can play with. But if we actually change here the spline position, you see that our terrain is being automated. Sorry, it's been changing automatically. And this is the value, I mean, the things we mentioned about non-destructive is that, yes, if you need to change, even after the scene is done later on, we can show that later too, you can change this later anytime you want, because it's all non-destructive and it's all being generated in real time. And let me just turn off these options because I'm adding a lot of randomness here. So here we have this, I have these options here, which are like the curl, strength, tiling, etc. If I just reset this guy, but you see something that looks way more similar to the triangle that we have. Then we can play with this. We can change the height up and down. We can actually create a plateau or a mountain-like if we uncap. I mean, all these details you can find in our video. But the most important thing that you need to know is, yes, you're able to generate these forms very quickly using the landscape brushes. You're also able to add randomness to this very quickly. Let's say 4. Yeah, very similar to what we had. The curl noise, just add noise to it and you know, make things dynamic. Then you're able to later to fine touch this by adding more blueprint brushes. It's not hard to add a new blueprint brush to the level. So here in the tool settings, we have the custom brush landmass. Just selected the brush that I want to spawn, added a new one here. And a good question that people usually asks me is, okay, we in the past when we were making landscapes, we actually needed to paint them. It was like a very manual manual way of developing it. You actually had to paint the mountains and everything. Then usually the workflow was that you could work on landscape in external software like DCC, like Maya or Blender, and then model that and then bring it to the engine as a height map. Or you could use other tools like World Machine to generate this very realistic mountains. And those are great. I mean, that gives you a great level of creativity, but these are destructive. Once they're exported from World Machine or from Blender, then anything that you need to do to your level, not anything, but if you need to affect these, then you need to change them in the original project and then rebuild them and then bring them back to the engine. And what the engine is really doing here, what landscape blueprint brushes really do, they have, I don't want to go a lot deeper here, but this is the source of a landscape blueprint brushes. What it is basically doing is exposing a lot of parameters, and all these parameters are going to be input into a material. And we actually have a few materials that we're going to use, and we're going to use some advanced material techniques like distance fields to generate a height map, basically. So a landscape is basically, I explained that really well in the video. It's a black and white texture that the landscape reads that to determine the height of a given vertex in the landscape. And what it really does is it gets all these parameters input to a material. The material gets all of that and renders to a render target that's going to be used by the engine as the height texture. That's going to be converted to a height texture and linked back to the landscape system. What it means is that using the tools that are the engine, this is not like some magic tool that you need to access using C++. You can actually do everything in blueprints and using the material system. You are able to create your own blueprint brushes depending on your needs of your project. That it's probably going to be used by some advanced users or companies, because of course you need deep knowledge about materials and math to do that. But this is not like a vanilla tool that you have to use what it comes with. You can actually expand that. So yeah, getting back to this, then we can add as many as we want. We can cap here, and let's create a lake or something like that. Let's change the angle here. It could be 20 degrees, 15 degrees, 35, let's say 20. Oops. And let's add some randomness. Probably make it a little bit smaller. Let's add some randomness to my lake.
You know, anyone who's ever used any, sort of painting landscape system to
Yeah.
build levels knows like what a challenge it is to create just a like uniformly flat area for a base or a lake, or
Yeah.
because these things are really important sometimes to be very even and flat for
Yeah,
gameplay.
that's
And
absolutely great point, Tom. Yes, and the landscape layer system, you actually let me create another layer, allows you to separate these brushes into different layers. There is a challenge when you're making levels for games, mostly for games. For other stuff, usually not, but for games, there is this challenge when you're building levels where you have stuff that is thought for the visuals. So you have like great visuals and a great environment, but there are some requirements that are game design requirements. So the level needs to have this, this, and that, because we want the player to experience this, this, and that. So the Fortnite team obviously have to deal with these challenges on a day-to-day basis. And the edit layer system is actually the kind of stuff that it's very powerful for these, because you can actually separate these into logical groups. Like you can have the visuals, but then you can have a different layer just for the flat areas, like you were mentioning, Tom, that you need to have, so you can build the houses, so you can have the roads and everything. And then since those are separate, it adds even another layer of non-destructiveness. So let's say you need to, I don't know, I want to revamp all the roads in the game, and then you have a layer for all the roads, and it's basically hitting that layer, adding another one, and experimenting, adding new roads and checking what is best.
And also for ArcViz, like I often did not use landscapes because of the challenge of finding flat areas and maintaining it. And I'd accidentally paint something, and now it's poking through the wall. And so, oh man, this is so cool to be able to just very easily define areas and have them like layers, because that works so much better in my brain, because I love layers and the ability to toggle them and decide that I don't want them after after a while is key.
Another amazing thing working with Blueprint landscape brushes is that, yes, we're able to, using blueprints and materials, we're able to paint the landscape height maps. So you can actually define the geometry, but using the exact same system, you're able to paint the landscape layers. And this may be a little bit confusing because you have the edit layers, which is layers where you can separate different edit objects that are going to affect the landscape. And we have the paint layers, which are the layers that we can use, the layer system that we can use to, set the different textures, different material properties for the landscape. So these blueprint brushes, you're able to paint dynamically the landscape paint layers to, basically by adding the layer that you want to paint. And it's so amazing because you're able to, have like a fall off. So it leaks a little bit, maybe a little bit less, maybe a little bit more. Let's leave it, like this. Then you can also add noise effects. You can also have, okay, let me see. Yeah, so I have the tiling noise here. Should be 4 should be fine. And then I have this noise. I can pick any texture, and what it's basically doing is adding some noise in the border, so it gives you these, natural painting. If you were to do that, even though it keeps the general form, but in a border it adds like this really nice natural variation. And if you were to do that manually, then you will be like painting this and clicking here and here and there, and then the
Right.
opacity was too much, and you have to erase and go back. So this is like just work. I can move this around. I don't want this lake here. I want this lake over there. And
I was just going to say, you spend all that time poking all those little dirt clods in, and then the gameplay testers say, "Oh, the lake needs to move over there."
Yeah, and then your life is ruined, and then you want to go back to.
We've all had to do it. It's just, and if this is why we do these streams too, is because if you don't know that this is there, and that this is the way that Epic is doing things, and that AAA game studios and even indie game studios are looking at how do we achieve, next gen stuff, is not with massive teams that are all out there painting in dirt clods. It's by making tools that you paint in dirt clods for you.
So fast too. It's so fast and iterative. It's crazy.
Yeah. And once you have one setup,
that's so sweet, Paul.
You can actually just copy and paste this. Okay, I have my lake. Then people on the internet, it's like, you need more lakes, and then you can just like
hold down the Alt key,
drag and drop, and then I have more lakes. And and non-destructive. I need to change all the lakes at the same time. Just select both brushes, and then I can change their parameters live non-destructively. In the end, and this is a thing that is important to note, when you actually go to the file package and you're going to package this to the final game, when you're going to build and cook all the assets, these are not going to be generated dynamically. We're not going to use distance fields or whatever, nothing like that. It's just going to be baked to a height map, to a texture. So this doesn't mean that you can use this system for real time in project, in application, or in game, like we like to say, to change the landscape. This is really built for, so we have like a non-destructive environment for the level designer, for the world designer. But once you export that to an application, then everything gets baked down to a single texture, for the sake of performance, of course. And the same thing with the layers. All the layers, they get baked down. You can have like a huge number of layers. Doesn't matter. That's not going to affect performance. It will be the same as you had an old, pretty good old landscape system.
As if you had painted all the mud clods yourself.
Yeah, as if you have painted all that.
So what we're trying to say is, if you're painting a bunch of mud clods, you might consider a different method. Not a lot of advantages to hand painting mud clods.
I remember at one point painting on rivets until I discovered that you didn't have to do that. But this is so cool.
Yeah, and there's the water system coming in Unreal. That's just amazing. I would love to be able to demo that today. We're going to talk a little bit later, but the water system is going to add yet another layer, because it will be able to just like generate a lake, and we'll do what this thing is doing, actually creating the hole, because it's like kind of like calculation erosion of the water. So you determine the area, and then you can pull a river, and then you have the river flow, the velocity, and then it will kind of like automatically calculate some of the terrain deformations for you. It's so awesome. There is a video from, of course, again, Ryan Brooks, on one of our streams, where he go a little bit deeper on that.
Or a lot bit deeper.
A lot deeper. Yeah, you're right. Okay. What we can talk next. I really want to talk, my favorite thing, and this, I want to send kudos to my friend from Australia, Chris Murphy. If you're not watching one of his streams or following him on Twitter, please do. Highly spammable on Twitter. And I really like to talk about runtime virtual textures. And runtime virtual textures is a feature that we added. I mean, this exists for a while in the games industry. One of the first games that have used it was Rage from Steam, from id Software. They used to call this the mega texture. And the runtime RVTs are really a way for us to have a really large texture that can be applied to like a really large level. And the secret for this is that, of course, if you had like a really large 24K resolution texture applying to your entire level, you will suffer very badly from performance. So the RVT, the virtual texture, that you're able to only stream parts of that texture that you are closest with. So it's basically like an array of textures, like a number of textures that are organized in a given way, where that when you in a given part of the world, the system will automatically stream that part at the highest resolution, and then as you get further, then it will stream like lower resolution, so we will never like really feel your VRAM, your memory with it. It's a really smart system, but Unreal takes it to a next level because within the editor, you're actually able to write to these textures in many different ways. The most common optimization that we use for runtime virtual textures is to, okay, this material in this landscape, one can say that this is actually a number of materials. This is a single material, of course, but you still have costs for doing, these transitions between the mud, the grass, and the rocks, and all the, the stuff that we do to get, the roughness and this really have this really nice effect between metallic and etc. So you're doing shader calculations, and this is all real time. Runtime virtual textures is a great way to bake it all out to a single texture. So you're not really doing a lot of math in real time, except then the visual part of it. But you're not actually doing a lot of calculations that is regarding to the visuals of that given object, of the landscape, in example. So you can bake everything down, all the material properties like base color, normals, and all the blends to a single texture, and just reuse that. And you have like a much better performance if you're speaking of a game that actually needs that performance.
It
But
also means,
sorry.
sorry to interrupt, but to me it seems also like, from an editor perspective or a designer perspective, it removes a lot of limitations, because you can, you don't really have to worry so much about shader counts and texture samples and whatever. And if you need to do some really complicated blending or whatever, it just gets baked down to a texture read. And that's really incredible.
Yeah, but it also allows, and this is like the nicest part, it also allows you to do some stuff creatively that was like kind of hard to do before. Let me save this guy.
Let me ask you a question
open.
real quick that's
Sure.
popping into the chat. There are people asking about whether this can be baked down and applied to a static mesh terrain. And so it's not specifically in the context of virtual textures, but can this work be baked down to static mesh texture? I mean, to static mesh terrain?
Yes.
Yes. Even in the context of a runtime virtual texture as well.
Yeah. You can actually, Unreal actually allows you to bake the entire scene to not directly to a static mesh, but to an FBX that you can then re-import later, or maybe open in another software. I actually tried that before with DScene, and tried to open DScene in Blender, and it works pretty well. It exports the UVs like just
very
perfectly.
nice.
Yeah. So moving on with runtime virtual textures, let me turn off the grass again. Touch that later. Let's leave just our. I can't have to do this here. Foliage. No foliage. haven't seen this. So there's a lot of things that you can do with runtime Vertex textures. But the one of the most, most use cases is to bake everything down to texture and use that bake to do transitions between models that are placed over the landscape. And here we have a good example. It's not that advanced, but what you're seeing here is that we have this Quixel model. We downloaded this with Quixel using the amazing plugin that Quixel Bridge can install to every Unreal Engine version. Unfortunately, I would love to be able to show that, but we are actually in 4.26 preview here. But it's very straightforward. So we just downloaded this, and what we are doing here, I don't know if you can see that, but let me edit this material, show you how this thing should look without any transition blending. So yeah, this is the original look of that material, of that object. And you see that you have a lot of hard blends here. If you add the grass, this will probably not be able to see that. But sometimes you're not able to add grass to all of the, let's say you have like a snowy environment, a snowy ground, then you can like add grass, and then you actually need these things to blend. And what it's really doing is that the landscape material, let me open that. We're gonna touch all that later because there's a lot of people who actually asks about how the landscape material is set up. We're gonna touch that. But what we're actually doing here is that we have the runtime Vertex texture, and then it's basically getting the base color, the roughness, and normal, and sending this to the runtime Vertex texture output. We're also saving the height, and this is really the absolute height. So the actual position of that pixel of the texture in the world, the Z position. And we do that because we can then reuse this data. Since this was saved to a texture, we can reuse this data specifically to do the blending. When we open this guy's material, let me show that. This guy's material, we have a dirty little secret here that we sample that height, the landscape height that we have just saved to a virtual texture. And we do like a very, very quick and basic distance check. And how we do distance, and this is important for you students, is that remember the math from high school. Yeah, this is actually a little bit important these times. So I'm getting the position of the landscape in the world, and I'm subtracting by the Z position of that pixel of the model, and then I'm going to divide by a distance, divide by a range. That's basically going to give me the distance, but I'm going to divide it, so it's going to create a gradient from 0 to 1, from the lowest point to the highest point. I'm multiplying this by 4 to get a little bit more contrast. And then saturating is basically clamping the value between 0 and 1. So I don't have anything lower than 0, and then I don't have any number higher than 0. And this I'm going to use as an alpha for the material blend. So what I'm doing here, I'm getting the main material, the thing that sets the textures, the material parameters. I don't want to go deep on that. And then I'm affecting those material parameters using the material attributes feature in Unreal Material System. Basically, just enable material attributes, and it makes it a little bit easier to do, this kind of different blends where you need to override or blend parameters, material parameters. So I'm getting the base color of the original visuals of the material, then I'm darkening it. I'm getting the roughness, and I'm multiplying the roughness to a lower factor, so it's going to be more like less rough, so it looks like it's wet. And then I'm also flattening the normals, re-inputting, and then we're blending here using that alpha that we are getting from from the world height. Well, this is actually the water height. Sorry. This is not, yeah, okay, sorry. But this is basically the same thing, right? We do that for the water effects. We do this for the blending effects. I'm getting the parameters from the runtime Verto texture. You can actually see here that it's saving the entire parameters of the landscape material to the texture, and I'm basically sampling it and blending, use the same technique, just doing like a very simple distance check with a distance rate blend, and where we're able to set this distance. Right now, our rocks material, the distance is set to 0. But once I start increasing it, then you see that the blending actually increases. I'm sorry for my neighbors.
They're just applauding.
Mm-hmm.
They're watching the stream. They're like, "That's amazing! Hit the walls."
And this goes a little bit deeper, and this is very specific to what we're doing here. That 200 is a lot. Actually, 50. Yeah, it's okay. 75.
That is so cool, by the way.
Yeah. We're not only blending material properties like roughness, but we're also blending the normals. What we're doing here is that because we're saving the world normals here to the Verto texture, and then we get them from the Verto texture, and then we do the transform so we can change them from world space to tangent space, and we're changing the material normals, and that's why we can't see. I mean, we can see, but this helps to hide the seam, the normal seam, a lot. This is actually working. World normal. Yeah, so you can barely see that there is
transition.
There's this huge difference between the surface of the normal. So it really helps it sit in the landscape. Sorry again.
That's amazing.
So yeah, and this can actually be applied to anything really that you want to add. And yes, don't forget, this is 100% automatic. So this is not like, oh, Paulo pre-painted that and prepare that with vertices. No, this is like, yeah, I want to add this rock over there.
I think it's also important to note that the updated material that comes with Quixel, with the Quixel Bridge plugin, has a version of this Vertex Blender with the virtual texture. So if you haven't downloaded the Bridge and updated the plugin, the latest material that comes from Quixel has a version of this. I don't know if yours you modified yourself, but they also have a video on their website that has a description of how it works.
I'm creating, I actually just modified Quixel to use this technique. I think that the latest Quixel material, they're actually using distance feuds to generate the same, it's basically the same technique. So I get the distance to, and then I do some little math to create the gradient from 0 to 1 to the lowest point to the highest point, and use that to blend the different materials. So yeah, sometimes you're going to see some seams, mostly due to the resolution of the Verto texture. These can be, of course, configured. I'm going to use like a kind of like a lower resolution for the sake of performance, but if you're working with something that actually needs precision here, then you can increase the resolution of the Verto texture. But from far, you can barely see. I mean, the rock gets really well integrated into the scene. Works really well.
That's fantastic.
And yeah, I was saying, we can actually bring this same thing, these blends, to anything that you want. So the grass, let me show the grass. You can see here is that the grass has a pre-configured color. The grass material has some color, but I'm actually using the Verto texture, sampling the ground color, and I'm getting a little bit of the color of the ground to make the grass sit better on the scene. So you see that as the grass gets closer to the mud areas, then it gets darker. So it sits really well, because if it didn't do that, then you see like this very greenish grass, like close to the mud, and then you will not. I mean, it would not like look that great.
Yeah,
And
no
you can
blend.
basically do that for anything. Sorry.
No blend. It wouldn't blend.
Yeah. So, and this is basically using these materials, basically sampling from the Verto texture, and doing its thing.
So cool.
I'm
It's
sampling
so cool. It's so accessible. Like, I've worked on games and projects where we've done stuff like this, where it's like, we got to get the grass to blend, and we've like made engine modifications so that the grass can read the texture, and like, oh, it was so hard. And now it almost is like it's right there, like you just showed. It's a
Yeah.
couple of nodes. Once you get it set up, I'm not saying getting it set up isn't trivial. But once you kind of figure it out and get it set up, it just becomes such a cool tool and unlocks so many neat things that you can do with terrains and with big environments like that.
Yeah. And this is, I mean, the setup is really that simple. Your material just needs to write to the Verto texture. And then we have these Verto texture volumes, where you're actually going to set in the world where this Verto texture is going to be rendered. And what it basically does is uses this volume to do the render, to set up the cameras and everything, which is going to render from that perspective. And then later on, if you want any object to be rendered to the Verto texture, then you just need to select the object, and that can be any object, and manually add them here. So you can see that we are rendering the world color and the world height to two different textures, which we're going to use around the world to create our effects. One last thing before we move, there's also the water effects, and that goes a little bit into the creatives. It's not really performance related. Sorry again for the noise. Is that these water bodies, those are planes, right? It's not like anything special. It's just like a plane with a water material. But this is being written to a Verto texture. The height of every pixel in this plane is being written to a Verto texture, and everything in the world can actually sample from this texture and use that to do any sort of interesting blends, like we're doing here, where these rocks, the same rock textures that we have mentioned before, we're using very basic height calculation to get that blend from 0 to 1, and then we're affecting aspects of the material, making it a little bit darker and making it look wet, and blending it out. And what we have here is that if we move this plane up and down, then you see that
Look at that.
the
That is
entire
so
world
cool.
gets wetter or drier. You can of course go crazy and do mud, or you can do all kinds of crazy stuff with it. Pretty powerful, even creatively, not only for performance or anything, but it's actually pretty flexible to create different sort of creative effects
So
for your scenes.
you can set up a master material pretty much, and then use your master material to do this for your environment for the most part.
Yeah. This is really what it's doing. This is the master material.
Yeah, that's what it looked
Came
like.
from Quixel. You see a Quixel Megascans integration.
Yeah.
And after that, I just added a bunch of stuff.
Gotcha.
Yeah. It's not that complicated at all, and pretty powerful. Yep. Good. I don't know how I'm doing with time, but
You're doing great. You're doing great. The quick clarification on a question that came through earlier about writing the actual texture to a file. Let me find it again. Let me read it so that I get it right. So again, in case you wanted to circle back, can you bake auto landscape material to a texture file and then load it back in Unreal or use it in an external DCC? So I guess the question is, if you're writing your virtual texture, you can export the whole virtual texture out and then use it somewhere else, or you can re-import it back in. Are you aware if that's an option?
Never really tried asset actions. Never really try exporting these.
Okay.
Yeah.
Yeah, no, that's just a
I don't.
I mean,
think that
definition.
it's a
probably
render
can do
target.
that.
So
Sorry.
it's a render target, right? So you'd probably have to do it at the material level. I don't know.
Yeah, you can
Give it a shot and
probably
let us
do
know.
that.
Send us an email.
Yeah,
in
you
the
can
stream.
probably do that, but you probably will need to circle around, probably do your own render target and sample from the material and write to a texture. And then a regular U asset texture in Unreal, yeah, so you absolutely can export that to PNG, or because the Verto texture is a little bit different. It uses different strategies for compression,
Mhm.
including colors, and very specifically different strategies for to save these high textures, because these are like they need like a higher dynamic range, because you're able to, like, save like really high values, like 100,000 blah 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 blah, because this is the Z height of the world.
Yeah.
So yeah, that may need a little bit of hacking, but I would say that would not be impossible. It's just probably not a feature that like simple, like right clicking export.
Yeah, I think what it's important to realize in the stream is that the material that's covering the terrain is a pretty complex material that's having to cover a lot of terrain, and so it's not there's a lot going on here. So you have to export at the material level, and the virtual texture is actually doing a lot to sort of, that volume has a lot to do with, if you delete that volume, your virtual texture volume, you're not going to see the same representation on the terrain mesh, right? Like that volume is actually doing the projection down. Is that correct? So,
Yes.
with regard to texturing terrain, the old way of doing it was you had to paint it manually by hand based on a series of layered materials, because you had a bottom layer, a middle layer, and a top layer, and you were basically exposing or revealing materials that you had to hand paint. But now what we're doing is we're using a volume and a virtual material through the system, and so that projection layer has everything to do with a render target that's being plopped down onto this terrain. So without that, you don't get a terrain material. So you have to export that, and it's basically calculating the UVs, doing a massive projection. Is that correct?
Yes.
So
yes.
you can't, you don't have one without the other.
Sorry.
Yeah.
Basically use that volume to project. Yeah, that's the word that I once was trying to get inside my head, to project like huge orthogonal projection from top to bottom, to bake that out,
right?
Get these parameters and bake the texture. I mean, the baking process is probably it's not really the thing here, the feature. I mean, even though it is, because it's awesome, but the feature really is that how these textures are saved to the world. And that's not even something that you can see like a regular texture in Unreal, because the way it's saved is different. It's an array of textures. It needs the way the data is saved is different, because it's optimized to be streaming. So wherever we're doing here, like say I'm here, there's actually a way to see the virtual textures. I don't want to go into that, but the area around me is actually using the higher resolution, sampling the higher resolution.
Right.
But that area far there is actually using a lower MIP.
Yeah.
And as I get closer, then it's just like
MIPing in,
erasing the other ones and loading these high-has.
Yeah, this is an evolution, right? Because last year and the year before, Ryan and those guys were saying, well, hey, look, we can do render targets, but we can do it in this really small space. And then they were like, well, why can we not MIP out render targets? And so then, that became the evolution into this technique using virtual textures, and then the volume projection, it's just starting the layer on. So I can't wait to see what this all evolves to, because it's becoming more
But
powerful at every turn.
One thing that it's important to notice is that runtime virtual textures are mostly not mostly, but they are real time in the editor. Ideally, once you export them, once you build the project, then they will just like get baked down. They will not like be rendering real time. So yeah, for some techniques, you may still need to use render targets.
I imagine. Yeah. I imagine there's some kind of atlasing that occurs. I can't imagine how when you cook the whole thing, it must somehow tile it or atlas it out so that it references it based on the streaming method.
Yes, that's exactly what it does.
Okay.
It's like it's basically like atlasing.
Yeah.
The texture is basically, and it loads, it streams
the tiles
the
and
proper
the
resolution depending on the location where.
Yeah, that makes sense.
Yeah.
Cool.
Yeah, one thing I don't want to skip, because people has been asking a lot about this, is the landscape material. This is not anything from outside of this world, my friends. We're using the regular layer blend node. We're adding a number of layers: snow, mud, rocks, grass.
There you go.
And then for each of these, I'm not even using height or advanced blending, just using regular blend. And here we have, this is just a technique. There's nothing out of this world. I'm just blending between the same material, the same material properties, but using different UVs. But this one is bigger, this one is smaller, and then I'm doing a distance blend. This is actually pretty old technique where you're actually using the same texture, but as you move farther, you load the same texture with less repetition. So you have this really nice non-repetitive patterns, or when you've seen the landscape from far. If I move closer, and you see that the texture is much more detailed, because it's just blending between two different UVs. If I move a little bit farther, you see that it will blend then to the same texture, but actually a larger UV. So you have like different, you can see like less repetitive features. So it looks like more natural. And basically, I'm doing the distance blend for the grass material. This is a material function. It's nothing really important to have like the grass base color, the grass variation that I'm using for roughness specifically, and the normal map. And I'm inputting that to this material function. And then I have the same thing for the rock. And then I have the same, I actually have another material for the mud. This is actually from not this one, but the material that the textures are actually from Quixel, Megascans, and then some random material for the snow. And then I'm just blended using the Unreal's landscape layer blend. If we go here and go to paint, you see that a landscape that is configured with a material that has the blend setup. And this is really all the blend setup that you need. Then you need to create these layer infos. It's going to carry some information, and I want to go into that. If you go under documentation, that's going to be explained really well. But then you have to create those layer info files, assets that so these landscape layers can actually be accessed by the landscape system. And that's really all that. This is all being painted, like I showed you before, all being painted dynamically using the landscape blueprint brushes.
So all you need is the height information, and it's going to expose the right layer. Are you actually leveraging the height information, or you do that manually?
No, this is the right layers are configured in the material.
Okay.
Right?
Yeah.
The material has the layer blend node, and here I'm configuring the layers. So I have grass, I have rocks, mud, and snow. The landscape itself, once I apply that material to the landscape, these layers are going to be automatically shown here.
Right.
For these to be accessed, you need to have the landscape
yeah.
layer assets.
Yeah.
You need to have this information files, or the landscape system won't be able to sort them properly. So, but it's
Right.
really simple if you need to create a
Yeah.
new one. Basically, like pressing
Yeah.
plus here. If there were, I don't want to do that. Because
Yeah, but you're not using a world position offset to change the material based on height
no,
at this time.
No.
But you
No,
could if you wanted to.
Yeah, everything has actually come. I mean, inside the engine is probably doing that, but here, no, not here. Everything is using the
right.
built-in landscape
Gotcha.
system from Unreal. So yeah, but yeah, I'm going to post this material online soon because people have
Great.
been making questions about this for a long time. But really, that's not much more than easily
Yeah.
set up landscape material within landscape and layer material within Unreal. So yeah, let's see what else. We can probably move to a little bit to procedural foliage now, which is two things. First, the grass system, and you guys let me know if I'm running out of time. First,
You're good.
the grass system. This is the grass system in Unreal. At least this one is very specific to the landscape system. So you basically only support a landscape for this because the way we place the grass is it's completely random, and it's faster for us to sample the landscape height to actually do the sampling and the positioning of these grass meshes. So that's unfortunately tied only to the landscape system, at least for now. And it's really done in the material. So in the material, in the landscape material, we have these procedural grass node. And what we do, we actually input a texture or a shader calculation here. So I'm sampling the rocks layer from the landscape. Don't forget that these layers are being dynamically painted. So that you not painting these layers. Layer density, maybe. Nope. Nope. Layer debug. Yep. So these layers are not being painted manually, even though I could, but we can debug them. We can see rocks. So yeah, let's add rocks on the red channel. Here is our blueprint brush. Let me turn off the camera. The blueprint brush is painting the landscape dynamically. So of course that where is red is where it's automatically painting the rocks layer. And our material get that layer, samples that paint, and applies the rock texture. Same thing for the grass. The grass is a little bit weird because everything is grass. That's just the way I've set up because I wanted that everything to be automatically painted. Same thing with the mud. So the lake blueprint brush is dynamically painting the mud layer on the landscape. And then we can, on our landscape material, we can actually sample the paint separately, paint layers. I can sample rocks or I can sample mud and do stuff with it. That's basically what I'm doing. I'm getting rocks. I'm getting one, then subtracting the rocks. So I'm going to get the inverted version of it, the inverted image. Then I'm subtracting from rocks from that image, subtracting the sample, the mud layer. And I'm doing some math here. Just, it's not like 100% contrast. I get a little bit of grass.
Yeah.
The mud areas. And then I inputting that to the grass, landscape grass output node. And here, I'm able to
pipe it into the layer. Yeah,
a grass type. Double click, and then I can configure different static meshes that I want to use. I have my grass, then I can change the grass density, add some flowers, much lower density, this thing.
That is so cool. I mean, that's how you would do it in many ways if you were painting it manually. You're just saying, don't paint it manually. Based on these variables, put your grass here, your mud here.
Yeah.
That's so much
Sample
smarter. It's
from-
procedural.
Sample. It is procedural. Yeah. Sample from the landscape layers where you paint, because it makes sense, right? You only want high
Perfect.
grass when where you painted grass. You don't want high grass on the rocks, right?
Exactly.
So yeah, get from the landscape layer, and spawn grass meshes only where the grass should be.
Can I say something real quick? This is so helpful and so accessible because, your video was great. It didn't go into this depth and detail, but, for you to break it down this way and to actually show us what the material's doing, I think, to be able to go back and rewatch this on YouTube in a little bit is going to just make, it so much clearer for people to be able to go, oh, that's what's happening. Because it was great to watch on your video, but it was also a little magic, now it's going to be a little bit like,
yeah.
because the math that you're talking about is just like, if you don't want it here, put less. If you want it here, put more. And then tie that to the procedural system. And there you go. And I'm like, okay.
If I do this here, if I am not doing this multiplication, and then we're going to compile our shaders. So,
and then it's going to do something different. Yeah.
And then what you're going to see is that, this layer alpha goes from 0 to 1. So I'm going to subtract the entire thing. So I'm going to subtract 1 where I painted mud. What we'll see is that in the areas where we have mud, we have absolutely no grass. And I need a new computer. But that should be coming soon.
Well, you shouldn't have bought a swimming pool.
Priorities, Lewis.
Yeah.
Priorities.
Okay. Yeah, that's going to take more than I thought. That's fine. That now we can talk about
80, 64. There it
there
is.
it goes. Yeah.
So yeah, now you can see that in the mud areas we have absolutely no grass.
Yeah.
We only have mud.
So that's why you wanted 0.5 grass. Yeah.
Yeah.
And that's so cool that even the procedural stuff feeds into that texture that the grass material can read. It seems like it shouldn't work, but it does.
Yeah, I'm using and then let's say like you painted a road on the landscape, or you actually have like a let's say a road mesh, right? With the texture, everything looks great. It blends with the terrain. It's pretty awesome. But of course, you don't want grass in that. And you can actually, merge these two techniques. I can have grass where the grass was painting on the landscape, but where there is a road that's using the vertical texture pipeline to render, I don't want grass. So I basically just subtract the grass minus the road vertical texture, and then I get the actual output where I want the grass to be placed. So there's like all kinds of possibilities.
Well, I like also that you can visualize by tying it to the channels and say, well, I can actually see what my formula is doing in the editor, and sort of actually have that visualization capability without having to guess what your material is going to do, right? That's super powerful.
Yeah. Moving on and speaking more about foliage, then we have the foliage system, which is the procedural dynamic foliage system. Let me re-enable that.
Yes.
And this is where this looks like really like more like magic, because we have these procedural spawner volumes. They're here. Let me find my foliage. Blah. Yeah, those are these assets, procedural foliage spawner. You have to, in the video I explained that really well. You have to have a procedural foliage system enabled. Then you have to create these assets. And then in these assets, you have to set up a foliage object. Foliage objects, they have different parameters. They are static meshes, but the way they're rendered is different because they're using the instance rendering. So what it basically is doing is that all these trees are being rendered in a single pass. They're being sent to the GPU in a single pass. Because if you were to send it tree by tree, then we're going to have a lot of draw calls and we'll have performance issues. So, and that's why this needs to be configured differently. This is the basic configuration, but here, when you have the procedural system enabled, then you have like all these options. And what this is really doing is, it is like if you had like a construction script that is tracing the ground and is using really nice, interesting algorithms to simulate nature. It's basically tracing the ground and say, what if randomly, what if I had a seed here, a seed of my vegetation, my plant here, and then it grows to a certain age, and after a certain age, it's going to spread more seeds around, and that's why when you do this, you have this empty space for no reason, but then you have like this very
Dense.
busy space, because this is actually really simulating that. This is like, I mean, there are a few trees here that are actually taller than the other ones because they're older, because they've been here for more time. But this is actually simulating life. Of
That's
course,
nuts.
it's like life simulation, but it's like approximation of life. And then you have like a taller tree that spawn more seeds, and then from those seeds, of course, you run a chance, and then more trees grow. And as you change these parameters, let me open this. You open the tree. As you change this parameter, so the collision radius. So if I increase the collision radius, so how large is my tree? Let's say it's 3 meters. Let's get back. And then I'm going to save that. Let me select my trees. Are these the trees? And then if I resimulate, then the trees are now larger, and the system is pre-configured for to avoid two trees in the same place. So they're larger, so we are less busy because they have a larger radius. If we're like 150 and resimulate, then we're busier now because they're thinner. Wow. And this is like all sorts of representations. We can increase the number of steps that the simulation will do. Let's say 5 steps. So we're going to have like older trees and younger trees, have more variation. Let me get back to 200.
Quick question. The source assets came from Boy and His Kite? The trees themselves?
Yes.
Okay.
Oh, no, not the source assets. The system was actually built for
Boy and His Kite.
Boy and His Kite.
So where did the trees come from? Because are these special trees that do this, or can you get any trees?
This is like just a regular static mesh that came from, I think, from these environment set that I downloaded from the marketplace.
Okay, so you don't need
pack.
special trees for this, or you do need special type of trees in order to work with the system?
No, just regular static meshes.
Wow, okay.
Yeah, I can actually open them here. So I have the foliage type, of course, where I configure all of this, but this is a regular static mesh. Of course, that it is better when you have a static mesh that have different LODs, because then you're going to render a lot of trees, and you're going to render a lot of them from distance. Sure. You don't want like very detailed trees being rendered when you're like far from them. You can actually see the LODs. You can actually, I don't know if
the billboard,
the resolution will allow us, but you can actually see them changing. Yeah.
Let me interrupt you for another second. A question came in: is if there's a sample scene that shares or shows at least some of this. Boy and His Kite does have the system in it, right?
Yes.
And then even the small sample scene from Boy and His Kite is using the system as well, right? There was a smaller version of it, but I don't recall if it had the foliage.
I think that we have an asset in the marketplace with just the assets, just the trees, right, and just the textures.
Yes, but not the system implementation like you have here.
No, it's not the system.
You'd kind of have to get Boy and His Kite to actually see the implementation of the procedural foliage.
Yeah, but I'm pretty sure that some of these assets in the marketplace, so the Meatle environment set, I think some of these are paid. I don't know if it's the Meatle or the Flowers and Paints Plants Nature Pack. One of them are actually free. But I actually had to buy some of them for these demo. But I think that some of these assets, nature packs in the marketplace, They usually come with demo maps that you can open, and they implement the procedural foliage system.
Gotcha. Cool. Thank you.
Yeah, and now I have, because it's 100% procedural, then you can have these kind of problems where you have trees over the water. Then I'll have to fix that later, but please. Oh yeah, this is actually an important thing. Let's open our tree foliage type. You can actually exclude landscape layers. Remember, always get back to the landscape layer things.
Mhm.
So I'm excluding muds and rocks, so I'm not spawning trees over these layers, only on the grass layers. But I'm spawning trees on the water because I'm able to spawn trees over static meshes, and I can filter them out here, just disabling that, and then no trees on static meshes. You can also have, I mean, I show that in the demo, but you can also have procedural blocking volumes where, let's say you want to have a house here, and then you can, not have trees here because that's going to be your house.
Cool.
Something like that. Yeah. Oops. So yeah, it's very powerful, but there's also one thing that we can use this for. Somehow my grass disappeared. I see. Oops. Please, grass, come back. Okay. You don't necessarily need to use this only for trees, right? You can actually use the system for, for other stuff like random rocks. So I have another spawner here where the foliage is not really a foliage, is a rock, a rock static mesh that I add, like I change parameters. Sorry, I'm lost. Yeah,
That looks like my my Chrome browser with so many tabs.
Yeah, I'm lost. Let's get back to the basics. So, did I stop sharing? Yes.
Afraid so. Now we can see what Mark's eating.
So let me open my procedural rocks.
Another cronut.
Yeah, and let me open the foliage type object and do some configuration here. And I'm not going to go deeper on it, but I recommend you to explore this a lot by playing. And I basically, have random rocks around my scene. So all of these instances of these small rocks here, they're randomly placed.
And Paolo, when they're randomly placed too, now they're part of the foliage system, right? Too. So if you wanted to go in and move a rock that got placed where you don't want it, you can do that, right?
You actually can do that. I think you can move a specific rock, I believe.
I believe so. I hope so, because I just said that you could. So
that's a good question. I don't think you can. Not in this case, because we are dynamically placing them in the world.
But you could put a blocking volume, yeah, or whatever.
You can delete these. If you want to delete a particular rock,
paint out an area.
Yeah, but the thing is that it is thought to be placed dynamically, and then you can control the areas where you absolutely don't want them using the procedural foliage blocking volumes.
Yeah.
And the filters that you have here, like you have the landscape filters. In the procedural spawner, you also have the filters if you want this to be spawned on static meshes, landscape, BSP, whatever. So, yeah.
Can I ask you a question real quick?
Sure,
so
all the questions in the world.
So when I remember when we did Buena's Kite, and I remember working with Sam Dieter when he was writing the documentation for some of these foliage, and And that was a while ago, right? Boy in the Sky was in 2015,
Yeah.
2015, 2016. And I don't know that we've internally used this tool with much frequency. And I'm not aware of a lot of people having used these tools. Maybe they have in games. I don't know. When you jumped in here and started using these, did they immediately work the way you thought they were going to, or did it take a little bit of like, what is this going to do if I do this? What is it going to do if it does that? Because
Yeah.
these are large systems that have things that are called things, and probably tooltips that were written a long time ago. What was your ramp up time in just getting, in particular, something like the procedural spawner system to behave the way you thought it was going to behave based on the way that things are called and the values? Can you just talk a little bit about that? Because I know that this entices me to want to work in it, and probably hopefully entices a bunch of people on the stream and people that are going to watch this video. But what was your ramp up time based on the fact that this tool was written, at this point, 5
Yeah,
years ago?
that's a really good question. And I would say that the ramp up time will probably vary the more experience you have with real time engines in general, because these two specifically, like the procedural foliage tool, is the kind of tool that if you have made games or real time applications for a while, you probably have thought of something like that before. Probably like you're making this game and then you're like copying and paste every tree manually by yourself, and you're like, man, we should probably have something that could do this for me. But of course, this will need to follow some logic where the placement of these trees will be like natural. They will look natural the way that they're placed in the world. So the ramp up time really comes for that. If you have more experience with these times of this type of real time rendering technology, you kind of know a little bit how these things should work, because you kind of like understand how the pipeline and how things are placed in the world and the kind of math that the engine needs to do. So it makes it a little bit easier. If you come from other areas, then I would absolutely recommend reading the documentation, because our documentation is awesome. And most of the problems that I face with this is that because I just jump directly into the feature and I can do this, I'm gonna handle this. And then once you read the documentation, there's like this very important snippet that you never read and didn't know, and then it changes your life completely. And this happens all the time. So yes, spend the time. Of course, that playing with the tool is awesome, because I mean that's the best way you can learn something new, is like just play with it uh, without being afraid of breaking it or whatever. Just play with it, try things. That's great. Things are going to get on your brain, memorized much easier. But uh, read the document. Read the document, because that's going to make you skip a lot of suffering in the future. And I would say that I have probably touched the procedural folder system. Speaking about time, Louis, about your question specifically, probably touched that before, but never really in a way where I wanted to learn this. It was like, okay, yeah, this is cool, and then I left it aside and went to focus on other stuff I was building at the time. I would say that I really had to explore this for recording this video. So then I would say, okay, I actually have to learn how this thing works. Then I went to read the docs, and then, oh, okay, now I understand the whole power of these. And I would say that like probably 1 or 2 weeks of learning.
Gotcha. Thank you.
Yeah, what we can talk. You wanted me to talk so much about water, so I'm not going too deep on the new water system. I'm going to show a few slides, but we absolutely have an amazing stream from Ryan Brooks about this. But I want to talk about these material shader, right? This water shader here. So water is not simple. It's not like a easy thing to solve in real-time engines, because water, it's a volume. You have to to simulate water surfaces, you have to maintain the characteristics of the materials at the same time that this material needs to be translucent. And translucent stuff in real-time engines are usually very expensive because you need to do all the sorting and etc. Water specifically is even more expensive because you not only need to do translucency checks, you need to change the aspect of the things behind the water, because the thing with me, the ray of lights are coming from the sun or from the light source. They're getting into the water. They've been altered, changed by the water material properties, then getting to the surface of the lake, whatever, and they will get there differently. So this is quite heavy and quite CPU intensive to do these simulations. But Epic, we have created a new shading model that we are using for our games and for stuff called single layer water. And this is really awesome because it's actually, usually when you do water bodies, you have to use translucent materials, right? And translucent materials are really expensive. They have all sorts of limitations, mostly regarding the rendering, the lighting model. They're not able to use the PBR lighting model because they're expensive, and many reasons for that. But the single layer water, it's different. This is not really a translucent material. It's an opaque material that renders the world without the water, and then after that, over that, then I render the water surface, but then I'm able to access the stuff that I rendered just before and do effects on it. So this is actually an opaque material. The water body you're seeing here is actually an opaque material that have access to what is being rendered behind. And then once I have access to what is being rendered behind, I can actually do anything I want. And change the color. I can do like the gradients that you're seeing. You're seeing this transition from a fully clear to this kind of like muddy water. Of course, that I'm also adding some forming some
normals,
the right word, refraction.
So it's not evaluating translucency
at all.
At all. That's ridiculous. I'm going to stop the stream. I can't take it. No,
okay, it's opaque, but you can see through it.
It's ridiculous. You can see through. That's ridiculous. Some big brain at Epic just says, well, let's just not have opacity. I mean, let's just not have translucency, but let's do it anyway. Let's let.
Yeah.
That's enough of that.
Someone someday say that, hey, we should make Fortnite like this huge island where you have water everywhere. And then some programmer were like, you can't really do that because water is going to be very heavy. And then at Epic, you have people like Ryan Brooks. I don't think it was Ryan who did that. I don't know, but he probably helped some way. But he has like lots of other people like Ryan Brooks. They're like genius, and they come up with these stuff.
It's exhausting.
Yeah.
But I love it.
And this is really just the beginning. This is just the shading model, because if we want to go a little bit on the water system, the new water system is a much deeper thing, right? It's a system where it's kind of similar to what we've seen with the landscape blueprint brushes, but it's basically going to create surfaces that are going to be used as water surfaces. So yeah, it's actually built over the custom brushes system, but then you're able to draw all kinds of water bodies like lake, rivers, oceans, and they communicate between each other. So let's say you have like a lake with a waterfall, and then you have the rivers and the ocean, and then they actually communicate and then blend each other like perfectly without like, I mean, you can see seams, but if you do it properly, you're able to like hide the seams really well. And all these things, they're not only communicating in a way where it's visually very interesting and very like realistic, but it also communicates to the gameplay. So this can actually be used for game. I mean, if you play Fortnite, you know what I mean. You have like all kinds of physics interaction with water now with the latest seasons. So yeah, I don't want to go too deep on it, but this is the kind of flexibility that you're going to have. You're able to have depth configuration, the velocity of the water flow. You're going to be able to, of course, configure audio. And the system, since it's based on the landscape blueprint brush system, the water bodies, the water rivers, they are able to affect the landscape dynamically. I mean, dynamically, not in real time in the game, but in real time in the editor. So it's the same thing. Like if you make this river and you painted everything and everything is beautiful, and then the game designer is like, okay, I need this river to go somewhere else. Then you just, in our system, you basically need to move a few spline points and make the change because it's completely non-destructive. So yeah, this is going to be really awesome. This we're going to have the first version of this in preview in 4.26. It's actually already in preview 4.26, and you'll be able to try this, and it's going to be live really soon. I mean, the preview versions are already live, but the final versions of Unreal of 4.26 are going to be live sometime soon. So yeah, this probably is all that we've got. I don't know if there's like anything else that you want to ask, or maybe you want to get some questions for us.
So I think this has been a remarkable stream, and in the context of the things you've shown, real-time virtual textures, the grass, the materials that you've shown, the foliage system, and this is a huge suite of tools, but then there's more, right? Like what we showed not that long ago, the cloud systems that are coming online in 4.26 is on top of the water systems. There's a whole volumetric cloud systems that are coming in 4.26 where there was a stream maybe a month ago where this is just absolutely ridiculous volumetric cloud systems coming in 4.26 as well, where you can have fully volumetric cloud systems that, so if you've got those distant mountains that you've got out there, they can be completely covered with these beautiful cumulus and nimbus and stratus clouds of all different types up there that, if you have a flying game, you can fly through deep volumetric clouds. So that'll all integrate with these systems as well. We already have the sky atmosphere system that you can go into deep space. And that was another one that one of our colleagues, is that in here as well, the sky atmosphere system? Yeah, you've got it in there. So that's the,
yes.
Can you just talk about this for a few minutes as well? Because this is part of the open world suite. And this is another huge, robust system. And point being is that what we're doing is bringing all of this stuff together, and it all integrates and works together, right?
Yeah, the idea, the sky atmosphere system, I'm not going to go a little bit into the details of how that works, but the original idea was that we do have something that we are actually able to generate a virtual atmosphere using physically based algorithms. In the past, for most game engines, sky and atmosphere were mostly simulated with some fog techniques that exists in games, and 3D games at least, for a long time, and textures. Really, I mean, for that still comes with Unreal. We still have like a huge sphere with a cloud texture that we do cloud panning. I mean, we're actually moving the texture over a blue material, and we change the material color based on the direction of the light. But that's all like really smoke and mirrors. The sky atmosphere system goes a little bit further because it is actually using algorithms to simulate how atmosphere is actually works, how can I say, it's a approximation of how the rays of the sun passes the atmosphere and then generates the tones of the sky that we see. And since it's like a physically based, because of that, you're able to configure the sky atmosphere system to simulate any kind of atmosphere, from the Earth or from other planets if you want.
That's amazing.
It really is.
Yeah.
And then, of course, we've got Niagara. So if you wanted to integrate those types of visual effects of all kinds, that all works with these systems as well.
Volumetric clouds.
Volumetric clouds. There's some new stuff coming for trees and foliage. Then we're finally able to use the procedural foliage system to procedurally paint actors. Of course, that you have to be careful about performance, but you maybe start using the procedural placement system for gameplay or maybe for interactivity, depending on the application that you're using. There are some other tools that are coming regarding streaming, because of course that most of the things here are these demos specifically is not very heavy, because we were using like a small landscape. It's probably like 1 kilometer or maybe 500 meters by 500 meters. The trees are all instants, so this is not like a single tree or a different tree being rendered. But if you're speaking of like a really large world, you're probably going to have like different instances of landscapes that are
Right.
very, very, very large, with different instances of vegetation that vary from a region to the other in the world. If you look at Fortnite, you have this really kind of like large landscape where you have snow, desert, different biomes.
Right.
And those are different assets. Those are different textures.
yeah.
Those are different materials. Those are different 3D models. And then there's upcoming stuff that is going to narrow the challenge of the stuff that you need to do to properly stream and load these assets to the memory dynamically as you move from point A to point B, from point A in a given biome with these assets to point B, that with different assets, and how the engine is going to automatically load and unload the older ones and reload the new ones. That's a huge effort that's probably absolutely needed for open world games, and of course that we're going to use. They're going to be used a lot and needed a lot for the next generation.
Right.
Since now we're talking a lot about the speed of SSDs and the streaming speeds.
Yeah.
The future games and next generation games. It is, of course, about graphics. It is, of course, about resolution, 4K, 8K, whatever. But it will be more about, at least in how the companies are portraying it, more about the amount of content and how you're able to navigate from a point to the other in the game without loading screens or without interruptions, without fake animations. So you're able to load different parts of your game, and how you can just go from one place to the other instantly, and just stream this data into the memory very fast.
I'll never trust elevators in video games again.
They're loading.
I'll always be assuming someone's loading something in the background.
Yes, they are.
Yeah.
Like,
We are probably about 5 or so minutes to the end of the stream, but maybe Mark and Tom, if you see any questions that we missed in the chat. In the meantime, I did want to ask you one question about the Blueprint terrain brush. Did I not see in the documentation that also had a road implementation where you could paint road erosions and that sort of thing?
yes, we do have it now, although it's a little bit buggy. I've tried using this. I should probably, well, we actually have Landmass River. That actually you're able to create river bodies, but then it will probably be replaced by the new water plugin that we have it right here, 4.26. Yes, you're able to create. I never really delved into it, but you're actually able to we have a Blueprint brush where we can input a mesh.
Put a roadway
and
there.
Then the mesh is going to be a spline mesh,
and it blends into the terrain, right?
Yeah, that we're going, and we're actually going to. I mean, it blends in with the terrain, but it actually changes the terrain geometry, overrides the terrain geometry, so it's flat enough for the mesh to actually, fit in the right place. But at the level, at least when I tried, it was a little bit not. It wasn't like really great at the moment to use that. It was a little bit buggy. But maybe in the latest versions, I probably for this demo, I should probably try to have a road here and yeah, add a little
Yeah, I
bit
thought I
more to
remembered
this.
seeing that. Did you guys see any questions, Tom and Mark, that we I know that there are a couple that popped through here. I thought I saw one about being able to use an 8K texture,
Yep.
import 8K height map with landscape layers to use this technique for customizing terrains.
Yeah, you can actually, let's say, if you want to import a landscape from world
World machine,
world
something like that,
machine or
yeah.
something like that, and then over that you can use the blueprint layer. Sorry, the blueprint landscape landscape blueprint brush assistant. You change that to alter that in some way or the other. You can actually probably organize that by layers. So these are non-destructive if you want to remove or to change the order of these layers later. But yeah, absolutely.
There's a question here. If he was trying to make a flight sim style game, what best practices or tweaks would you do in order to make the components more performant?
Flight sims is a different kind of beast when you're speaking of how to render the scenario. Mostly the scenario of a flight sim is the clouds. The ground is really mostly the background. I'm not necessarily the right person to it, but I would say that I'm not sure they use something that's too similar to the landscape systems that we have in engines. It's probably in a very approximate version of that. It's probably very close to a landscape system, but it's not as complex because landscapes. Don't forget, there's a lot of stuff that you need to evaluate. That's not only height or how you're going to render those vertices, but the height maps are also used for collision, for tracing collisions. So there's really more thought for when you have a character and you're walking around and then you have enemies and you have like other stuff. So, but they probably do something similar for that. But I would say that for performance issues, that's like a custom implementation. We're going to have there's a tool coming to Unreal that will allow us to do some sort of these more interesting custom implementations. I think it's actually live in 4.26 preview. I'm not 100% sure because I don't want to say names without that. I don't know if they should be said, but there's stuff coming that to be able to help you to implement stuff like that. But keep in mind, there's very custom. It's not like it's a generic system for you to implement something on top of it. It's not like it's going to be like make your flight simulator and it's ready. Just press here. No, you actually will have to do some custom implementation for that.
Cool.
It's an interesting question. When you start to deal with, and I think that this is dealt with probably in part with the LODs, how would you recommend customizing the overdraw that you would get from such massive foliage systems?
Yeah, that's a good question. Well, the first one is, of course, the LOD system is going to help you a lot with that. And the LOD system, and by that I mean also like basically not rendering the trees if you're like very far from them. Of course, that all these trees they're not like fully alpha blended. They're using masks. They're using opacity masks. That helps a little bit too with the alpha and the transparency.
There's also I was trying to find a tweet, and I'll see if I can find it here. That Chris Murphy, Mr. Highly Spammable, he posted a while back some INI settings that you can use if you've got projects with lots and lots of foliage.
Yes.
And one of them is using the early Z-Pass to calculate the blending, so it basically can reject all the transparent pixels, so that it doesn't even have to render those.
Yes, that's exactly what I was trying to remember
Yeah.
for. Is yes, there is this INI. We'll have to look into Chris' Twitter to find that out. But yeah,
I'm frantically trying to find it.
Yeah.
I found it like 3 days ago, and I posted the INI things, the 3 lines that you need to enable that.
Yeah.
But
that
in
makes a
the end-
huge difference.
in the end, there is not really a magic here. I mean,
Yeah.
if you have a lot of surfaces that are transparent, then
Overdraw is an issue.
your-
Yeah.
then your GPU will tank. So you have to be careful,
Be careful.
about it.
Profile often and early, right? That's
Yes,
the magic
and
sauce.
it really depends on the kind of experience, the kind of application that you're making. Sometimes, if you, I don't know, by some reason you have a game where you actually have to fly from a bus and fall on the island using a parachute, and then you actually need to see the entire thing from a distance, from above, probably will need to use like other techniques like HLODs and
Mhm.
proxy meshes to render your trees, your forest, until you're like close enough. Then the engine will switch them to the regular rendering
Right.
techniques that they're like more thought for, this kind of experience where you're actually walking around.
And there have
a
been talks
forest.
done, for that from the Fortnite team. They talked about some of the
Yes,
imposter systems.
I'll absolutely check our
Yeah.
GDC talks from 2019, where they're talking about optimizing Fortnite for mobile. And yes, there's a lot of very interesting stuff, very interesting techniques that they use to render forests, render vegetation from far distance.
And then sometime in the future, we'll try and see if we can get Chris Murphy to stay up till 2:00 in the morning to do a stream with us. 'Cause, maybe we'll pump
He
him
will.
up with
He will.
coffee or something. He's a great guy. We're good friends, and but it's awfully late right now in Australia. Paulo, this has been an amazing stream. We thank you very much for taking the time to spend these couple hours with us and share this amazing stuff. Your video was great. I think going into this depth and explaining these things to the stream and the education community has been super valuable. I think, Tom and Mark and myself and everyone who joined the stream was probably really thrilled to be able to go into this depth and understand these next gen techniques and see how the engine handles it, and to be able to see how it all comes together and kind of peek underneath the Wizard of Oz and see that it's not crazy magic, that most of us will be able to access these systems is what it's all about. So thank you very much again. And any final words, gentlemen?
I know what I'm doing this weekend now.
Mhm. I'm compiling
building a
shaders
world.
right now.
I would actually love to share this scene with the world if only we were not using like paid marketplace assets, or maybe we can like try to come up with a cleaned up version only with Epic assets and maybe Quick, so that we can distribute.
Yeah,
That
well,
would be
we'll,
great.
we'll figure
Yeah.
out something or whatever. Yeah. Well,
Mhm.
thank you again. I hope you stay safe, and I hope you all stay safe out on the stream. And we will see you next Friday. We've got another amazing stream, which is called Becoming a AAA Animator. We will have some great epic animators. We've got Jay Hosfeld joining, and who else is going to be on the stream? We've got a couple of guys from the Fortnite team. Cody Belmer will be here, who's another animator who does a lot of the emotes, and we're inviting a couple of other guys to come talk about, the role of an animator in AAA gaming. So this is part of the series that we do about becoming a AAA developer. And then a couple weeks from now, we're going to be doing another stream about using the Variant Manager, which is another great system in the engine. That you typically see used in the enterprise space. They use it a lot in automotive and manufacturing, but it can be used for so many things. So we're going to be working with Daryl Obert, who's one of our marketing product specialists to jump into the Variant Manager and see how it can be used not only for enterprise users, but also maybe even for gameplay. So that'll be another exciting stream. So once again, thank you, Paulo. Thank you, Mark. Thank you, Tom. And thank you all in the stream. We hope you have a great weekend, and we will see you next Friday.
Bye, everybody.
Bye. Have a good weekend. Good Halloween to those who are doing Halloween.
Yay.